Bismuth, a review. Bismuth is the most metallic and least abundant group 15 element. Bismuth is hard, brittle, lustrous, and coarsely crystalline. Its only stable isotope has a mass of 209. For a long time, bismuth was not recognized as a separate metal. That was until the middle of the 18th century, and works on its chemistry were published. In 1739 by German chemist Johann Heinrich Pott, and in 753 by Frenchman Claude-François Joffre. Bismuth is as abundant as silver, contributing to about 2 × 10⁻⁵ weight% of Earth's crust. It is found in veins associated with lead, zinc, tin, and silver ores in Bolivia, Canada, England, and Germany. Its naturally occurring compounds are bismite, bismuthnite, and bismuthite. Commercial bismuth is produced largely as a byproduct in the smelting and refining of lead, tin, copper, silver, and gold ores. Pure bismuth can also be obtained by reducing the oxide with carbon or by roasting the sulfide in the presence of charcoal and metallic iron to remove the sulfur. One way of extracting bismuth is known as the Betterton-Kroll process, which is widely used for removing bismuth from lead by adding calcium and magnesium to a molten lead bismuth bath. Compounds are formed with bismuth that have higher melting points and lower densities than lead and thus can be separated as a solid dross. Bismuth can then be recovered from calcium and magnesium by treatment with chlorine. Treatment with sodium hydroxide then produces highly pure bismuth. An alternative separation known as the Betz process involves electrolytic refining of lead bullion, containing bismuth and other impurities, in a solution of lead flowsilicate and free flowsilic acid, with bismuth being recovered from the anode sludge. Separation of bismuth from its oxide or carbonate ores can be effected by leaching with concentrated hydrochloric acid. Dilution then precipitates bismuth oxychloride, which when heated with lime and charcoal produces metallic bismuth. Metallic bismuth is used principally in alloys, many of which it imparts its own special properties of low melting point and expansion of solidification. Bismuth is thus a useful component of metal alloys which make neat, clean castings and is an important ingredient in low melting alloys called fusible alloys, which have a large variety of applications, especially in fire detection equipment. Bismuth is a rather brittle metal with a somewhat pinkish silvery metallic luster. Bismuth is the most diamagnetic of all metals, i.e. it exhibits the greatest opposition to being magnetized. It is hard and coarsely crystalline. It undergoes a 3.3 expansion when it solidifies from the molten state. Its electrical conductivity is very poor, but somewhat better in the liquid state than in the solid. With respect to thermal conductivity, it is the poorest of all metals except mercury. A bismuth-manganese alloy known as bismanol has been found effective as a permanent magnet. It was developed in the early 1950s by the U.S. Naval Ordnance Laboratory. The material was generally strong and stable to shock and vibration, but tended to chip. Slow corrosion of the material occurred under normal conditions. The material was used to make permanent magnets for use in small electric motors, but has now been replaced by neodymium magnets. Small concentrations of bismuth improve the machinability of aluminum, steel, stainless steels, and other alloys and suppress the separation of graphite from malleable cast iron. Thermoelectric devices for refrigeration make use of bismuth telluride and bismuth selenide. Pharmaceutical uses of bismuth have been practiced for centuries. It is effective in indigestion remedies and anti-syphilitic drugs. Slightly soluble or insoluble salts are utilized in the treatment of wounds and gastric disorders, and in outlining the alimentary tract during X-ray examination. The alimentary tract are the organs that food and liquid travel through while being digested. Sometimes bismuth is injected in the form of finely divided metal or as suspensions of its insoluble salts. Substantial quantities of bismuth oxychloride have been used to impart a pearlescent quality on lipstick, nail polish, and eyeshadow. Bismuth is relatively non-toxic, the least so of the heavy metals. It is generally not an industrial hazard. Although bismuth and certain of its compounds find considerable therapeutic use, some authorities recommend that other remedies be substituted. Soluble inorganic bismuth compounds are toxic.